Adding or subtracting fractions. This illustrates why we have to find a common denominator if we're adding or subtracting. If we attempted to add or subtract without finding a common denominator, it would be like trying to do this. What's x plus y? Cannot add because the sections are not of the same size. So if they're not of the same size, we can't add them. We need to get one of those bars, both of those bars, to be broken up into the same number of sections, and then we could add or subtract. In order to add or subtract the sections, they must be of the same size, which translates into the need of a common denominator. And remember, a fractions, we have a ratio, 7 sections from the 10 available. Take 7 out of the 10. 7 out of the 10. Finding the least common denominator is finding the least LCM, the least common multiple of the denominators. So take 2 over 15 plus 4 over 21. Well, first find the LCM for 15 and 21, which is the least common denominator, is 105. So now the denominators you had originally, instead of being 15 and 21, we've changed them both to 105 and 105. But we can't change the denominator, adjust the denominator, unless we do the same to the numerator. Otherwise, we're changing the problem. So how did the 15 become a 105? How did the 21 become a 105? Well, if you look at step 3, the 15, if you multiply it times 7, becomes a 105. So just make sure you multiply the 2, the numerator, by a 7 also, and that gives you a 14. For the 1 over 21, how does the 21 become a 105? You multiply it times 5. Just make sure you do that to the top. That gives you a 20. So now we have 14 over 5 plus, 14 divided by 105 plus 20 divided by 105. Now you could add them. So you copy the denominator, you just copy it. Notice we're not adding 105 plus 105, we just copy it. And we're taking 34 parts out of the 105 parts that are available. Here's another example that has to do with finding a common denominator. This is an algebraic one. It involves variables. If you look at the denominators, or better, if you see these two, these are two fractions, but the denominators do not look the same. So what you do always when you're working with algebra, factor everything you could factor in the numerator and the denominator. So if you look at the denominators, 6 minus 3x, we're going to factor out a 3. And notice 3 times 2 is 6, and 3 times negative x is negative 3x. So this factorization is correct. Right here, you could factor out a 3. So 3 times x is 3x. 3 times negative 2 is negative 6. They still don't look the same. All we did here was factor. But we get lucky because now the denominator, this denominator looks like this numerator. You could cancel it to 1. Anything over itself except 0 is 1. Same here. But notice right here we had to do something else. These don't look the same. So what I did is I factored out a negative. I factored out a negative to be able to switch the order of these two terms. And I switched them so they could look like the ones in the top. Or you could switch the top so they could look like the ones in the bottom. In this case, this particular problem, we're going to make the top one look like the bottom one. So I'm going to factor out a negative. And that switches these around. Notice if you multiply this out, you get the same thing, so it's correct. And now the advantage of having the same numerator and denominator and it's being multiplied, you could cancel it to 1. So this leaves a negative 2 over 3 here, and over here a 1 over 3. Now you could go on with a simplification. 1 minus 2 is negative 1, and you just copy the denominator for an answer of negative 1/3.